Perfect. There we go. Okay, guys. So proving trig identities. Usually what you want to do is choose one side and stick to that side. And your job is to make one of the sides look like the other side. Usually you're going to choose a side that's more complicated. When I say more complicated, that just looks more complicated or might have some trig functions that don't have sine or cosine. Because sine or cosine are kind of the more basic trig functions, right? So anything that's not sine or cosine, you can convert it to sine or cosine using the previous identities we talked about last week. And so some tips: transfer the more complicated side to the less complicated, convert everything in terms of sine and cosine. Consider some algebraic skills like factoring, fractions, combined fraction, expanding, foiling, maybe conjugates, perhaps, difference of squares. Always try to keep in mind, I mean, obviously the goal is the target expression. So think about what you got to do to the side you're working on to make it look like the target expression, right? You could try both sides. If you feel like one side's not working out for you, then maybe go back to the drawing board and try the other side. But I don't want you working on both sides because I want you to, I want to force you to use identities, right? So you're going to choose one side. I'm going to make that a requirement. But if one side is not working, like you just run into a brick wall, then maybe go back to drawing board, go back to step one, and try to make the other side look like the side that you were working on. And again, you got to use all the identities you've learned in the past. So that's kind of a nutshell what we're doing here. So we're gonna do a lot of these. I'll get us start the first couple, and then I'll have you guys try 3 and 4. So for number 1, I'll probably work on the left side. I mean, it's hard to tell which one's more complicated, but if I work on the left side, I could probably convert tan and cotan to sine and cosine. So I could probably do this. Let's go to red. I could probably say that's sine x over cos x. We agree with that, right? And the other one's cos x over sine x. And I'm a little lazy. That just means a double quotation means repeat, right? So just do that. Don't rewrite it over and over again because it's a little pain in the ass to do. Just do the little quotation marks, right? Now, because I changed left side like I did, we should probably put in the LCD. What is the LCD here? Least common denominator. Yeah, just cos x sine x, right? So I'm going to multiply top and bottom by whatever it's missing. And I'm feeling pretty good about this now because I think I see what's happening, right? If I look a step or two ahead, I'm most likely going to use a Pythagorean trig identity. So what do I got for myself here? Sine squared x plus cosine squared x equals, over sine x times cos x equals the other side. So by making the denominators the same minus two fractions, right? Now, what does that equal? It's not going to become 1. There you go. Using the Pythagorean trig identity. So it's 1 over sine x times cos x. I'm out of space, so I'm just going to kind of mosey on over here. And that's 1 over sine x times 1, because I could break apart the fractions, right? No harm, no foul. You could decompose fractions like that, so you have to be fluid with your fractions. Well, what's sine x? Cosecant, and what's cosine x? 1 over cosine x. And now, is it verified? You bet. You can have your little check marks. And so that's a very easy one. I'm also going to challenge you with ones, but pretty straightforward, right? Okay. It's good. So let's try another one. And then I'll have you guys try example 3 and 4 in table groups. So I'm going to try to sneak in, because I didn't give myself enough space, but I think I could try keep the previous part. Let's try sneaking in here. I'll do my best. I might need to erase. Questions? No? We're okay? All right. Now, in this case, what is more complicated? I don't really know. Like, it's kind of a tie. If I choose the left side, what am I going to do? Probably do the conjugate. If I choose the left side, I'm probably going to multiply top and bottom by the conjugate of the denominator. What does conjugate mean? Change the opposing sign. Yeah, go with the opposite sign. Totally right. So you wind up getting cos x, cos x plus cos x sine x over
Mr. E.
So
you're doing an identity. Can you change both sides?
No, we're only gonna change one side.
Yeah.
Yep.
How do you
Yeah, no, if you cross multiplied, you totally would verify it, but I'm trying to force you to use more algebraic skills. So I'm challenging you. Yeah. No, if you cross multiply, it's done, right? But I don't want you doing that. All right. So what does the top, what does the bottom become, guys? Yeah, 1 minus sine squared x. Oh, bless you. And up top, I'll factor out cos x. Okay, so it was kind of dumb of me to actually distribute because I need to separate out anyway. So that was actually kind of lame that I did that because the whole point is for things to cancel anyway. So actually, I don't know why I distributed the cos x. So I'm kind of spinning my wheels a little bit, but I'm on the right path by spoiling those two binomials in the denominator, right? What does that become? 1 minus sine squared x. Yes, that's another Pythagorean trig identity, just a variation of the Pythagorean trig identity. So if I replace that, so cos x times 1 plus sine x over cos squared x equals the other side. Now, what happens to the cos x's, guys? That becomes 1, and that becomes just cosine x. And now I have it verified. Check. So it's verified. So in order to get it started, I have to do the conjugate. Now, if I start on the right side, I think with the same work, right? If I start on the right side, I would have done 1 minus x to the bottom. Still would work, but then fine. So it's up to you. There's no right or wrong way. Just have to make sure it's the end of the same things, right? So, and I probably could have worked on the right side for example 1, but I think it was easier to work. This one's not. Like changing a tan and cotan seemed easier to do. I don't know. So yeah, just sometimes just depends on what you're given. All right. So why don't you guys try examples 3 and 4? I'll freeze my screen. Then we'll check in. So I'll give you guys about 5 minutes. Do examples 3 and 4 in table groups. Oh, example 3 is easy. That's really easy. That's too easy. You guys only need 5 minutes for this. Yeah, I think these are pretty easy. You guys get that? Yeah, I think it's just a couple steps to be honest with you. That's cosine squared x, right? It's cosine squared x line. And reverse it, blah blah blah. I took just x. Here we go. That's nice. Example 4. The left side's a bit more complicated. Change cosine and cosine or sine. Change tan sine or cosine. But change tan sine or cosine, the cosines cancel. But it's true in the sine x. The sines cancel cosine or sine. You have sine squared x. Well, that's verified from that. So. Okay, question on examples 3 and 4. All right, let's keep moving. Next page, we got 3 more here. So let me do example 5 with you guys. I'll have to try example 6, 7 in your table groups. And then we'll move on to some more juicy stuff. Right. So example 5, I would consider factoring. Factoring is a big deal. So you have cosine squared x minus sine. I did not leave myself enough room. Here. cosine squared x minus sine squared x, cosine squared x plus sine squared x equals the other side. And what's cosine squared plus sine squared, guys? 1. And now it's verified. Okay. Go and try examples 6 and 7 in your table groups. It is, isn't it? You know what I would do for probably example 6? That's a little tricky. Maybe start at the right side.
Oh yeah.
I'll put a little question marks. I'm not 100% sure. Definitely start with the left side for example 7. Bless you. Bless you. Okay, I'm gonna freeze my screen. I'll work it out. We'll check in about 3 minutes. How you guys are doing? Actually, start with the left side for example 6. You might be fine with the left side. I don't know. It is? Okay, you know what? Don't listen to me. Start with the right side.
Okay, start with the right side.
Or do listen to me. I don't know.
No, I
don't think it's necessary.
No, there is a solution.
Yeah, and then you braid it.
I think it's yeah, I got it. Boom. Wait, I think I have it.
Yeah, it's fine. Work on the right side. I got to work.
Yeah, I got it. I multiplied the top and all then you get. I did not do that. I don't think I did the same. I didn't like it when I said I got it. That's just. Also, you were a budget.
No, but no, actually.
You don't know what a budget is? Never heard of budget. Whoa. No, it's 1 minus sign. What? Oh, and then it's the same thing.
Oh, and you.
But whoa.
Oh, and then one of these becomes sine squared. Oh, one of these becomes sine squared. Because one.
Yeah, I got it. Did you also square the cosine on the bottom? Yeah.
All right. Oh, I thought it was frozen. Oh well. Okay, there are my answers, guys. So I started the right side of example 6. The part that makes it a little tricky is realizing what to do about sine squared A being multiplied tan squared A. If you convert sine squared to 1 minus cosine squared, so be fluid with your identities, then I see, oh yeah, now I think I get sine squared minus sine squared A with cosine squared, break apart the fractions. Break apart the fractions, oh yeah, I get tan squared A minus sine squared A. So keep the target expression in mind, or you work on the left side too, that's fine.
It's just fun with like the gradient sign.
Right, and then for example 7, the left side is more complicated, then you get 1 plus x with cos x. We already did this earlier. So this is an extension of the previous idea we did, I think number 4, I think.
Yeah.
Just do the conjugate, it'll be fine. Questions? Yeah, no questions? No, we're good?
What's the back? Yeah. I'll just.
All right, let's keep moving. All right, so these are, I think, a little more fun. Sum and difference identities. So these are ones you have seen before. First off, this is not true. I'll tell you now, that's not going to work. So the key thing here, sine or any trig function is not distributive, guys. Please don't do that mistake. That's a big no-no. So it's not going to be distributive, just so you know. But just to verify, let's do it. You have sine of 2 pi over 6 plus pi over 6. Sine of pi over 3 using unit circle, that's root 3 over 2 plus 1/2. That becomes sine of pi over 2, which is 1. 1 clear does not equal root 3 plus 1 over 2. We know that's an issue, right? So it's not distributive, guys. So don't do that. No trig function there is distributive. So just like we worked at PEMDAS, right? You work out where to study parentheses, right? And then you do the trig function afterwards. So, just PEMDAS. So that's not, so what do we do instead? We have formulas for these, right? The formulas are on the next page. Sine of u plus v, or whatever letters you want to use for the 2 angles, is this. I am going to ask you guys to memorize these and it sucks. Actually, except that. I'll give this to you. Yes. But I won't do the doubling. Because you're gonna of course get the right. I'll give this to you. And the reason I'll give this to you is that some of you guys who are doing ACT exams, like if you're junior or bigger sophomore, might do it like next fall. We actually give this to you all as a camp. So I'll give these to you. So I won't give you some of the other ones. But these I'll give to you. So sine of u plus or minus v is that. Cosine of u plus minus v is that. And just the minus plus, it's a little confusing. If you got a plus between the u and v for the cosine, use the minus on the other side. So you have to go in the right order. If I did plus to the sine, I get the plus, or minus to the minus. But it's opposite with cosine. Cosine of u plus v is always done minus the, or cosine of u minus v is always done plus cosine. And then tangent works this way, but it's reversed to the bottom. You have to be mindful of the direction of these plus minus or minus plus signs. So we're first going to actually evaluate some angles that are not on the unit circle, but we're going to force the issue at the unit circle to make this work. You want exact value, so you can't just plug in the calculator, obviously. You got to find exact value. So cosine 75. So what you're going to do is find 2 angles after 75, but angles that you can identify from the unit circle. What 2 angles can I combine to get 75 that I can identify from the unit circle? Go ahead, Brady. 30, 45, really good one. If you want to get a little creative, you could say 120 minus 45 if you wanted to. I don't know, it's up to you. But let's just keep it simple. Let's say it's cosine of 45 degrees plus 30 degrees, right? So what am I going to say then? It's going to be cosine of 45 degrees times the cosine of 30 degrees minus the sine of 45 degrees times the sine of 30 degrees. Now I know this is in the first quadrant, so I expect the answer to be positive. Root 2 over 2 times root 3 over 2 minus root 2 over 2 times 1/2. Final answer is root 6 minus root 2 all over 4. because I get 4 when I multiply the fractions out to the denominator, and because you have the LCD, you can combine the 2 fractions to 1, right? So let's get a couple steps. That's 4. We multiply this out with 6 over 4. That's root 2 over 4. And it's not the same, so I combine the 2 fractions. If you want to check, see if you did it right, you could easily pull up a graphing calculator. I'll do it right now for myself. See, math department. Here we go. So, if I do cosine of 75, and by the way, I got to switch to degree mode. Or if I do root 6 minus root 2 all over 4, same thing, right? So I know it works. Dude, good. Doesn't matter. No? It's commutative. Doesn't matter. Won't matter. Yeah. If you got a different answer, I might make a careless mistake. All right, guys, let's try another one here. Let's do a sine. So pi over 12. How am I going to combine things to get pi over 12? What would I do? Yeah, I'll probably do pi over 3 minus pi over 4. Yeah, that's a good idea. So you got to think a little critically here, guys. Oh, pi over 3. Here we go. And why does that work? Because pi over 3 minus pi over 4 is 4 pi over 12 minus 3 pi over 12, which of course is pi over 12. Okay. Well, so now let's work this out. Sine of pi over 3 times cosine of pi over 4. So I'm using that formula. And there's a minus, I have to put a minus also. Cosine of pi over 3 times sine of pi over 4. That's what? Root 3 over 2 times root 2 over 2 minus 1/2. We get the same answer as we did before. We get the same answer, as we should, because that's 15 degrees, guys. That's 15 degrees. That's a compliment. So you should do the same. You get the same. Okay, go and try part C on your own. You don't have to rationalize the denominator. Actually, I advise you not to. It's not necessary. Go and try part C. Yeah, you're gonna do 3 pi over 12 plus 4 pi over 12. That would make sense, right? Which would be pi over 4. So you got tangent of pi over 4 plus tangent of pi over 3 over 1 minus what's that going to be? Root 3.
Do we just keep it like that? Or do we have to specify?
I'll tell you in a sec. Okay. So here's the deal, guys. Overall, this quantity overall negative or positive? Negative, because it always be negative if 1 is less than 3, but the top force is positive. As it should be, instead of pi over 12, it's that greater than pi over 2, less than pi over 2.
It's great.
So it's been said quadrant, tan is negative, so I expect negative answers, so that's good. Now, personally, I don't care if you have the rock on the bottom, I don't, so you can leave it like that, it's totally fine. It's totally fine too.
If you wanted to go a little further, you could, but I'm fine if we leave it like that. So no need to rationalize the denominator. That's totally fine. I think what I'll probably do for a question like this to just make my life a little easier for grading,
I'll probably make some multiple choice question. Say, here's this, which you put math to that, and of course we knock it out. But yeah, I think that's what I do.
just so you know not to go much further than you have to. Now, these problems here are a little strange because I don't know what pi over 12 is of cosine exactly, or sine pi over 12, or even e. I don't know what tan 11 or tan 4 is without a calculator. But if you're somewhat clever, let's just compare this to the other side of the trig identity, right? Like here I see a cosine, cosine, sine, sine. So for part D looks
Often like the right side of that identity, right? So I can just go back in the direction. Then I go in the reverse direction.
I could just say, well, this looks like, for part D, this looks like U, this looks like V, this looks like U, this looks like V. So it's cosine of U times cosine of V minus sine of U times sine of V, which is really just cosine of U plus V, exactly. Or cosine of pi over 12 plus pi over 6, which is cosine of pi over 12 plus 2 pi over 12, which is cosine of 3 pi over 12, which is cosine of pi over 4. What's cosine of pi over 4, guys? Thank you. Now,
Once you see what this is, once you see what those things add to, hey, more power to you. You just go, oh, that's pi over 4, and go for it and get the answer. But I just want to be a little more drawn out just so you understand how I got that angle. But again, you have to recognize the fact that, oh yeah, this is the difference part of cosine, right? So that's what I'm going to do. Identify U and V, combine it, hold it, and then work it out. You should find.
so we'll do something likewise for E. Go and try E in your table groups. Hopefully it's pretty obvious what you have to do. So this is like U. This is like V. That's like U. That's like V. Is this an addition or the difference? Is it sum or difference, guys? Sum, totally. Okay, guys, quiet down, please. So 60, that's root 3, I think. Yeah, root 3. Okay, questions? No, we're good. All right, let's keep moving. You guys doing great. All right, you're practicing your water polo skills. Yeah, yeah.
Weird shoulder flexibility.
All right.
Weirdly.
All right, example 9, guys. Let's keep moving. Now, these problems are good problems too. You have to figure out which quadrant you're in and then work it out afterwards. Before I get too carried away with drawing these angles, remember, this is just sine A times cosine B. And to be honest, I think you'll want to just memorizing these when you do this enough, because you'll do this so many times. And once you see the double angle formulas, I think you'll just know what to do with these. But I'll give you something. Okay, so that's what I'm doing. I already know sine A. I already know cosine B, but I don't know the other ones, right? So what quadrant is angle A in? What quadrant is angle B in? 2. Totally. Good. So I'm going to draw this. And I'm going to draw this. Now, label appropriately. Sine, opposite over hypotenuse. Therefore, that's 3. Cosine, adjacent over hypotenuse. So that's going to be 5. Now you work it out. Sine of angle A is 4/5. Cosine B is -12/13. Cosine A is negative 12/13. No, I lied. Cosine is 3/5. Sine B is, because this is for A, and that's for B. What's sine B? 5/13. Did I do that correctly? Yep. So I get negative 48/65 plus 15/65. She should get negative 33/65. Now, if you want to verify
They've done this correctly. If you want to verify they've done this correctly, you could do an inverse straight function. You do inverse sine of 4/5, which I know is a weird angle. You do inverse cosine of 12/13, some obtuse angle. Add those two angles, take sine of it. You should get that. Actually, I'll show you really quickly.
if you want to, and I remember that's how I used to do it, because there was a standardized test you had to take called ST subject test many years ago. And I forgot these identities, but that's what I would do to work around it. I wish I was paid more attention in pre-cal. Exactly. If I did this, right? And if I did inverse cosine of negative 12/13, add that to this bad boy here, take the sine of it, it's the third quadrant, should be negative. And if I do negative 33/65, I think we're gonna be okay. Yep, we're okay. We got the same thing. Yep. Okay. Let's keep moving. Questions so far? We're good? All right. Let's prove the following. Okay, this is a co-function identity. Now, I know this is true, guys. I know they're going to equal each other. But, guys, quiet, please. But we're going to use a difference. We're going to use the difference identity. So we're going to do cosine of pi/2 times cosine theta plus, that's the opposite, sine of pi/2 times sine theta equals the other side. What's cosine of pi/2? 0. What's sine of pi/2? 1. Is it verified? You bet. So that's how you can prove it.
So now you learn multiple pathways to prove this stuff, right? It's not just a circle or plug in numbers or seeing exactly what's happening, but you can use an identity too to prove that this has to work. Okay, once you guys try example 11, so you're gonna draw the double angle. That's why I'll give you some formulas, not double angle, because you can write it. So go ahead and write it. What you're gonna want to do
To get kick-started, is think this x plus x, where this is going to be u, and that's going to be v. So your job's to verify this identity.
I didn't know. Yeah, it's too I think I do hard. I'm not going to do it. Which would be triple angle is good.
Yeah, it'd have to be cosine to x.
You have to match it.
Yeah, it's pretty easy, guys. So it's like combining like terms. Because sine times cosine is the same as cosine times sine. Multiplication is commutative. Okay. So again,
If you use a sum formula, sine of x plus x, it's sine x, cos x plus cos x and sine x. Well, duh, they're the same thing. It's like saying 3 times 4 and 4 times 3, you know, they're the same thing. So if it helps us to rewrite this, sine times cosine, sine times cosine is cosine times sine. These are identical expressions, you have two of them. So divide by
And you can do likewise for cosine 2x and tan 2x. You could derive those formulas by using the sum difference formulas. Okay. Questions on this one before we do the next one? All right. Now, for example 12, here's what I do. Think of this as cosine of x plus 3 plus 2x. Okay, that's how you're gonna want to get this thing started. Think of it like that first, and then you'll have to do another sum formula in the intermediate steps exactly. With this cosine 2x and the sine 2x. So I'll give you guys a few minutes to look at it to work through example 12.
Maybe a mistake.
What's fine.
I think I actually got it right. Yep, I got it right. Number 4.
that's interesting.
Yeah, I don't know. So actually, you're gonna make it a sine or cosine. That's what you're gonna do. No, it'll work out. Okay, guys, keep on example 12. I'll gonna work out right now.
This is 1 plus the other over 1. Mine plus 1 minus. There's the plus minus and then there's minus plus. So on the top they add each other. Cosine 2x would be tangent x minus tangent of the 2. Is that right? Minus
Oh, just something to remember.
no, I just made that right here. Bottom plus x.
How do you know this is? Use cosine x plus to see where that gets you. Use that. Use this again. Just use this and simplify. Don't make it simplified the way you can't.
Cosine x minus sine x.
Use that. Don't make it under square. Multiply that by
This change might be.
you'll get it. One. It's undefined. Cosine 0. It's undefined that by cosine. No, cosine x cubed minus sine squared x. It's 1 over 0. It's negative 1 over 0.
I'm so confused.
And then you add to that this number.
I don't think I'm doing this right.
No, dude.
But you can't do fantasy football, right? So
Josh,
Oscar, I'll help you next week. Okay, I'll help you out.
so 13. That's undefined.
That's undefined.
Great.
Yeah.
It's undefined. I give up.
That is a fact undefined.
And maybe they want us to solve it from the other side.
What's he be talking about? All right.
Oh, wait. No. Stop laughing. You're making the sign over cosine? You're making the sign over.
All right, guys, let's talk about it.
Oh.
So the trick here is break part 3x is x 2x. If I do that using a strong formula for cosine, u will be the x, u will be the 2x, right? So you have u and b, x and 2x respectively. The cos x times cos 2x minus sin x times sin 2x. I color coded so you see exactly what's happening. Let's run these things. So cosine 2x is cosine x plus x. If you work that out, you can do another sum identity there. That's cos x and cos x minus sin x times sin x. Once you get the other bits, you'll learn cosine 2x is that. Actually, there are a couple other variations of this. There's like 2 cosine squared x minus 1 and 1 minus 2 sin squared x, but that's for another day. Let's talk about that. And then green, that's one example. I don't know how to do that over again. Just taking the pretty good example. Then when you distribute and combine like terms, cosine x sin squared x, 2 sin squared cosine for x like terms. You just reverse the multiplication there, and you want to have to verify.
A little more drawn out, but it's a good one. Okay, we're good? Yeah, all right. 13, let's prove that one next. Now, here's what I do for 13. To make your life easier, think of a sine of x minus 3 pi over 2.
But why doesn't he like?
Because tangent 3 pi over 2 is undefined, that's why. Yeah. So it's a workaround. And then you should get sine x. Let me think here. Guys, quiet, please. Thank you. Times cosine of 3 pi over 2. Minus, no, plus. No, it's minus. You're right, thanks. Cos x times sine of 3 pi over 2. A lot of things are going to cancel it very nicely. And then that's going to be cos x times cosine of 3 pi over 2 plus sine x times sine 3 pi over 2. Well, what's cosine 3 pi over 2? Good, I like that. So you got, so that just goes away. And sine 3 pi over 2 is -1, so it becomes cos x times -1. Down below, you have another 0. Then plus sine x times -1. So you wind up getting cos x up top, negative sine x down below, negative cotangent x. You have verified.
Who told you to?
Okay, we're okay there? All right, so we're at the home stretch. Just 2 more examples and we're done. Okay. So we're not gonna go over homework. We'll go over homework on Wednesday. These notes are a little longer today. I think they'll be a little shorter next time. So you guys been hanging tight. I know it's been a long day for you guys. All right. So we're just gonna solve this, right? You're just gonna do the identities we've been doing all along. Sine x times cosine pi over 3 plus cos x times sine of pi over 3. Now I'm going to color code. Sine x times cosine of negative pi over 3. Sorry, my bad. Still pi over 3. But minus cos x so you should be getting this. Sine x times 1/2 plus cos x times √3/2 plus sine x times 1/2 again minus cos x times √3/2. Things should come out really, really clean now. They should come out extremely clean. If you clean things up correctly, what should cancel? Right. And you have half sine x plus half sine x, which is what, guys? Just sine x. And we know what that is. What's sine x equal to? Boom, there you go. And I'm not asking for general solutions, just from 0 to 2 pi. Yep, just pi over 2. Yep. Okay. Last one. Okay. So you're given a little hint. You're asked to square both sides. So it's fair treatment. And then we got to find the third negative solution afterwards. So we're going to start by doing this. Cos x plus 1 squared equals sine x squared. I'll let you work it out. I'll give you guys about 5 minutes. We'll check in, and then we're done with class. So again, we're not going to do homework for you today. Do it on, so work it out, guys. I'll freeze my screen. A little hint, change sine squared x 1 minus cosine squared x. That's a little hint, guys. Use the Pythagorean trick identity on the right side. Should be A-okay.
I feel like that's better than our two cosine. No, that makes sense. Cosine is 1. So cosine x plus 1 is equal to 1. Cosine x is 1. Right? Cosine x equals 0. All of it. Take it into plug in I over 2. Plug in I over 2. Yeah, works. Oh wait, no, that's mine. No, I'm just negative 3 power 2.
Oh, yeah.
I don't even know what I did. It's great fun.
This one, I ended up with
I over 2 plus 5k and I plus 1. It's 2 cosine x. Where? Wait.
Yo, are we eliminating the solution?
Guys, there's gonna be an extraneous solution, by the way. There will be an extraneous solution.
Is that like
It works, but you don't count it. You get it, but it won't count. I'll show you guys. There is. This way. There is.
Okay, hold on. Let me try to find it.
I didn't see it first either, so I don't blame you for not seeing it.
Whoa.
So
I didn't even have those functions in my phone. I don't these use the solutions.
Oh.
But then 270 will work for each side.
Yes.
Because
Well, also, the fact if you plug in 270 back in, that's -1, but that's 1 on that side. So 271.
So you're saying.
So then it's just pi over 2 and pi.
Pi over 2 and pi are the three pi over 2s will be extraneous.
Yeah.
3 pi over
That's
2.
what I got. Looks good. Now.
Because if you throw it back into the original equation, it won't be satisfied. Yep.
So then you would just consider pi over 2 and pi,
Right.
and then pi
Right.
over 2 minus 4 pi would be your third negative.
It'd be negative. Wait, pi. Say again.
It would be
Pi minus 4 pi.
because pi over 2 minus 2 pi would be your first negative.
I got 5 minutes. I'll share with the class. Hey, all right, guys, let's go over it, guys. Okay, here we go. All right, let me walk you guys through it. All right, two square both sides. Okay, you guys quiet. Don't come stretch. I know it's been a long day. Thank you. Two square both sides. Foil. That's good. Change the sign square one minus cosine square. Select all the terms on one side. The ones cancel. Back with cosec's. So cosec's got to be 0. Cosec's plus 1 is 0. The cosine x plus 1 equals 0. Cosine x equals 1. That's pi. Cosine x equals 0. You get two answers from 0 to 2 pi, right? Full rotation in circle. Definite pi over 2, definite 3 pi. Here's the part I actually didn't see this myself. I had to look at the solution case, I'll be honest. I didn't see it myself. But you do have to check to make sure it satisfies the original equation. Because we square both sides, the opportunity for extraneous solutions will arise. Because when we square things, they stay positive, right? So pi over 2 is okay, because cosine pi over 2 is 0, 0 plus 1 is 1, sine pi over 2 is 1. 3 pi over 2 is not okay. Cosine sine 3 pi over 2 is negative 1. Cosine 3 pi over 2 is 0 plus 1 is not equal to negative 1. That's extraneous. Pi is okay, that's 0, and it's going to be 0 as well. So you only have these two answers. So the general solution would be pi over 2 plus 2 pi k, in case I didn't use it. Or every odd value pi, or you say pi plus 2 pi k, that works too. Or k pi, where k is an odd integer. Once you have that, then you do this. You have pi over 2, you go backwards, negative 3 pi over 2, negative 7 pi over 2. Here you have pi, negative pi, or negative 3 pi. So that's your first one. That's your second one. That's your third one.
Wait.
So third would be negative 3 pi.
Why is negative 3 pi?
Into negative 2 pi because it's you want cosine x to be negative 1. Cosine 2 pi is 1.
Wait, why is 3 pi over 2?
You go back in, that's gonna be negative 1, that's a good one. Because we squared both sides, that's why. That's not what happens squared. Okay, go ahead, sorry. You have questions? Yeah, you have to. I'll remind you guys to do that. Oh, because that's minus 2 pi. Because you have to go 2 pi backwards. No, the negative part 2 is extraneous. It's pi over 2. Yeah. The negative part 2 is fine. That's okay. All right, guys. We're all done. Finally. In the video.